Hello everyone and welcome to this video. Today we're gonna discuss the limits and we're gonna evaluate some limits in the xy plane and with more than one variable. So let's start now. Start with the first example. So we have the limit as xy approaches 0, 0. Now we're gonna take x minus y, x plus y. Now if we directly substitute 0, 0 into the function, we're gonna get 0 over 0, which is an undetermined. Now, what can we do about this? We can start by checking if this limit exists or not. We can try different paths. And what I mean by different paths is that I can assume x to be 0 and then evaluate the limit as x goes to 0. So this is gonna be 0 minus y, 0 plus y, which is gonna give us minus 1. Now let's try setting x equals y. Now this is a different path. We can have many different paths in which we say, for example, x set it to any number. So we can set x to 0, we can set y to 0, we can set x equal to y, x equals to y squared. We're gonna try to prove that the limit does not exist first. So we are basically trying to find a counter argument that the limit does not exist. If we could not find that, then we can proceed with other methods such as converting to the polar coordinate. So here, if we go to the limit as x approaches y, now we're gonna have y minus y over y plus y. Now this will give us 0. Now, since different paths give us different answers, then here we can say that the limit does not exist. And that's why we usually start with trying to prove that the limit does not exist before trying to evaluate that limit using, for example, alternative coordinates, which we can try using in different examples. So now to the second example. So x, y, as it goes to 0, 0 of xy over xy, absolute value of xy. Now, if we directly substitute, we're gonna get 0 over 0. And this is not desirable, so let's try now to do something like trying different paths. So let's say first let's try x equal to y. X equal to y is gonna give us the limit as x approach y, or y squared over square root of y, absolute value of y squared, and then this is gonna give us basically 1. Now let's try doing x equals minus y, see what this gives us. So as x approaches minus y, we gonna get minus y squared over absolute value of y squared, which is minus 1. So the absolute value of minus y, so which is minus y squared over y squared, which is minus 1. And since we have different values with using different paths, then the limit is said to be inexistent. So the limit does not exist. So then we can go to example C. So the limit as xy approaches 0, 0 of x squared over x squared plus y squared. Now let's try to substitute. So if we directly substitute, we're gonna get 0, 0. Okay, so now we're gonna first try some different paths. So let's start with x equals to 0. It's gonna give us 0, so no. So if we try x equal to 0, I'm gonna get the limit as x approaches 0 of x squared over x squared plus y squared, which is basically 0 over 0 plus y squared, which is 0. Now let's try x equals y. Limit as x approaches y will give us x squared over x squared, sorry, y squared over y squared plus y squared. It's gonna give us 1 over 2. So different paths give us different values, so the limit does not exist. So yeah, most of the limits here do not exist. And then we're gonna try d. D is basically, I think it's similar to a. Yes, it's exactly like a, so we're gonna skip that. Let's go to e. Let's go to example e. I think that's an easy one. Let's see. So it says x plus y over sine y plus 2. Now if we directly substitute, we're gonna get 0 plus 0 over sine of 0 is 0 plus 2, which is 0. So the limit is 0. So this is direct substitution. We do not need to try anything. Now let's go for example 3. So example 3 says, what value of c makes the following function continuous at 0, 0? It's an interesting question. So first of all, what makes a function continuous? Basically, the thing that makes a function continuous is that the limit at a specific point, let's say xy, as it approaches, let's say here 0, 0, of our function f of x, y. To be continuous, we need to satisfy two conditions, or basically it's one condition. So we need to have this one condition satisfied. We need this limit to be equal to f of x, the value at f of x, y. Basically, this is the condition. So we need the limit. So this is the criteria for for a function to be continuous. We need to find first the limit of it. It should exist. Okay. The limit should exist, and also it should equal to the value of the function at that specific point that we are trying to test for continuity. So let's try to solve it now. Let's solve it here. Example 3. So f of x, y equals x squared plus y squared plus 1 if xy is not equal to 0, 0. So this is our condition. Then c, if xy equal to 0, 0. Interesting. Okay, so we want to find the value of c. So what value of c makes this function continuous? So we need basically to find the limit as xy approaches 0, 0 of x squared plus y squared plus 1. We want it equal to c. We want to find c. So if we substitute 0, 0, we're gonna get 0 squared plus 0 squared plus 1 equal C, and then we're gonna have C equal 1. So this is the value of C. And that's all. Thank you for watching this video. I hope you enjoyed.